I'm going to move on. And if you're having difficulty, then this might be a time for you to come in after school. Because in 10 minutes I can set you right. But because there's 30 kids in here, I can't spend 10 minutes with even one kid, you know? So if you're not getting this, if you're not able to successfully draw rays 1, 2, and 3 and back them off to get your image, then come see me after school. And I'd say any day, not just Monday or Tuesday, any day, and I can set you right on these ray drawings. Because some people have a tremendous facility with this sort of thing, and other people find it impossible. It's like knots. Some people can tie knots really well. You show someone, here's a square knot with a double half hitch, and they go, oh, boom, 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 here it is. And then there's other people where I can't tie a knot if you showed me 1,000 times. My brain doesn't work that way. You know what I mean? I mean, you do knots. All the special types of knots that do special things. I can't figure knots out. It's just not in me. So if you're that sort of person, you know, come see me. Okay. So look at the brutality thing. Here. Look at number 10. Okay. Number 10, 11, and 12 is going to summarize what we've learned in these 3 ray drawings. Because I want to remind you, we've done 3 ray drawings, right? We did
How much is
we did one drawing. Here, focus, center. We did one drawing where the object was to the left of the center, where the object distance was greater than the center of curvature. And when we did that, we found that the image was here. The image was closer to the vertex than the object, and the image was reduced in size, and the image was inverted. This was the very first ray drawing we did, where remember the object distance was 7 and the image distance was 5.25. The object height was 1, and the image height was like 0.75, something like that. That was the first one we did, where the object is to the left or beyond the center of curvature. Then the next drawing we did was this, where the object was between the center of curvature and the focus, and we found the image was still real, the image was real, but the image distance was farther than the object distance, and the image was enlarged. We had an enlarged image, not like the first one where the image was reduced. And then finally, we did one where the object was between the focus and the vertex. And when we did that, now the image went virtual. The image is virtual, the image is enlarged, the image is upright. So let's go ahead and answer number 10 together. For a concave mirror, if the object is located between the focus and the vertex of the mirror, you get a what kind of image? Good, virtual. Please write that down. Otherwise, what kind of image do you get? Real. Please write that in as well. Look at number 11. For a concave mirror, if the object is located between the center of curvature and the focus, like here, then the image will have a magnification that is what than 1?
Greater.
Yeah, greater than. And I should, specify that that's the absolute value of the magnification. That just means the image is going to be enlarged. Yeah, greater than 1. And then read number 12. What do you suppose that is? Sure, less than. For a concave mirror, if the object is located beyond the center of curvature, then the center of curvature, then the image will have a magnification that's less than 1. By the way, what if the object is located right on the center of curvature? What do you suppose the magnification is going to be now? 1. Yeah, 1. And that's what I accomplished with that demo back there. I have the light bulb that's in the box, the upside down light bulb, is precisely at the center of curvature of that mirror, so that the image is directly above the light bulb. Yes?
You have a magnification of 0 where all the light converges at a single point before it splits off again?
Yeah, a magnification of 0. I'll tell you, Theoretically, yes. You tell me. Well, if your magnification is d sub I over d sub O, what kind of d sub O is going to get you a magnification of 0?
Infinity.
Yeah, infinity. Infinity. So the most convenient thing we have that would give us a magnification of approximately 0 is what? What object do we have access to that's almost infinitely far away? Yeah, the sun. The sun's 93 million miles away. And so when I get the image, you know, when I get the magnification, the sun is a dot. And then what do I use with that dot?
Oh, you can use magnifying glass like burn paper.
Yeah, to burn paper, right? That's what you use. You can use a mirror or a magnifying glass, which is a lens. You use a mirror lens to burn stuff. And in that situation, you're shrinking the object. You know, the sun is this several, 100,000 mile diameter sphere that you're shrinking down to a point so that you can burn paper. And in that situation, you're getting a magnification of pretty much 0. But the object has to be infinitely far away. So does that answer your question? Yeah, you do it all the time. Okay, great. Now, it is time to talk about the convex spherical mirror. And I think I'm going to just power through. I don't know. Yeah, let's power through, because this is going pretty slow. Then when the bell rings and it's time for snack, that's when we'll have our break. And you'll get you can go to the cafeteria and I think they'll give out free food. Yeah, like a small apple juice and a muffin. Why, is that what they give out, muffins? Oh, good for you, Brian. I feel really blessed to be in my No, I think it's like 10. Yeah, 10 or 15. What?
Oh, I got you.